Hello students, in our last class we have learned some of the concepts of our chapter 3. So now we will proceed ahead with some more concepts of the chapter how many squares, okay. Now let us check how big is my hand. You can compare your hand or the area occupied by your hand by any of your friend. So how do we find? See, we can do it by keeping our palms together, okay. When we keep our palms together, we can find the difference in area of the two palms, okay. The palm that is going outside of the other palm has a greater area. But how can we find the area in centimeter square? Let's do it. As in the next page, a diagram is given having squares of area 1 centimeter square each. So when I keep my palm over here like this, let me draw it. I need to draw the boundary only. Let us assume that this is the boundary of my palm. Fine. So how many full squares are there within my boundary? I don't find any, but there are some squares which is within the boundary of my palm, having covering the square more than half, just like this one. This is half. This is also half. This is not included because it is not covering more than half. This is also not included because it is less than half. This is also not included because it is also less than half. This is very small. This is also very small, less than half. So I can go for these three squares, and each square either full square or more than half, okay, they are taken as 1 centimeter square. So I have 3. So what should be the area of my palm? It is 3 centimeter square. 1, 2, 3. 3 centimeter square. You can also put your palm in the diagram given, and you can draw your boundary and count the squares. Those are full or more than half or more than half, and take all the squares as area 1 centimeter square, and you can find out the area occupied by your palm. Fine. Now let me show you something. I am drawing the same diagram again. Assuming each square is having area 1 centimeter square. Let me spread my palm like this now and draw the boundary of my palm. Fine. So now let us check how many squares are within the boundary which are full or more than half. This is more than half, this is more than half, this is not included, this is also not included. This square is included because it has area more than half. All this square I can include because altogether it is more than half. This is not included, this is not included, this is not included. So I have 3 squares and here 4 square. So total 4 squares, or the area is 4 centimeter square. So when I spread my palm, this is the area occupied by my palm. You can also do it by yourself and find out different areas. As I have already told you, area is nothing but the space occupied by an object. In this case, the object is what? It's our palm. Fine. You can also find out the area of your footprints. You can find out the area of the footprints. You can find out area of any uneven surface. What does it mean? Uneven surface means the surface having non-uniformity. The even surfaces are your rectangle, triangle, square, parallelogram, trapezium, rhombus. All these are uniform surfaces. We can find out the area of all these two-dimensional surfaces by applying formulae. But for uneven surfaces, just like this is an uneven surface. I can find out the area of this surface by applying any formula, but I can use the graph paper like this to find out the area of such uneven surfaces. We will study about all these things later on. Okay? Students, in your next page, we are going to learn about finding the area occupied by the skin of different animals. How can we find out? We know that some animals have their skin folded. So, more the fold, more is the area of the skin. Why? Because see, if it's a flat surface, suppose this is a square, okay, if I fold it, I can fold it like this to get a triangle, isn't it? But it is folded square. It is folded square. So, it actually occupies the area of this much, which is being folded. So, if I stretch the skin, the folded part of the skin and spread it somewhere, it will occupy more area. Suppose this is the skin of any animal which is being folded. I see it like this, but if I open it, open the folded part, I will get a rectangle, isn't it? If I open the folded part, I will get a rectangle which is definitely having more area than this right angled triangle. So, it looks as if it is occupying less area, but if that skin is unfolded and spread somewhere, we can find out that it will occupy more area. So, it is understood now that the skin that is more folded will occupy more area. That is why the baby rhino which is having there in your book, okay, the skin of it's having more area than the skin of the elephant, because the skin of elephant it's not folded more. Rhino, its skin is more folded. What about the ant? It is having very less area because it is having very less skin. Same way we can find out the area of the footprints of different animals and birds. As it is given in your book, you can see that the footprint of a hen, it is occupying an area having some squares. Now count it down and find out what should be the area of the footprint of the hen. I know you can very well find out the area of the footprint of that hen. Let's go to the next page. In this page, you have a graph paper of having squares of 1 centimeter square area, and there is a footprint of a tiger. So now I hope you can find out the area of each part of the footprint and sum them up to find out the area occupied by the footprint of the tiger. Can't you? I know you can, because I hope you have understood how to find out the area of any uneven surfaces. Okay? So do it by yourself. So students, let's go to the next page. It says how many squares in me. As you can see, there are two rectangles. Okay, let me draw it first. This is the first rectangle having two squares. Okay, so first rectangle having two squares. Assume each square is having area of 1 centimeter square. So the total area of this rectangle is 2 centimeter square. Now it is divided into two same triangles. So area of each triangle will be of 1 centimeter square, as the rectangle is divided into two same triangles. Okay, so area of each triangle is of 1 centimeter square. So now we can find out if we divide evenly. If we divide evenly, we can find out the area of each part. For example, this is a square of area 1 centimeter square. If I divide it into two parts, okay, so each part is of 1 by 2 centimeter square. If we divide it into four parts, so each part is of 1 by 4 centimeter square, and so on. So let us find out some more areas including the squares. So as the question says, write the area in square centimeter of the shapes below. I am doing the area of the square for you, and you have to find out the areas of all other diagrams. Okay, so let me draw it for you. This is the graph of having square. Each square is of area 1 centimeter square. Fine. So if I draw a square like this, okay, so what we see that it is covering half of the first square and half of the third square, half of the third square down below and half of the third square down below. So what should be the length of this? This is your 1 centimeter, this is half centimeter, this is half centimeter. So in total 2 centimeter. Same way, this is 1 centimeter, this is half centimeter, and this is half centimeter. So in total 2 centimeter. So area of this square, let us check by calculating the squares. This is full, okay, 1 centimeter square, fine. So this is half, so half centimeter square, this is half centimeter square, this is 1/4, so 1/4 centimeter square, this is half centimeter square, this is also half centimeter square, and this is 1/4, 1 by 4 centimeter square, fine, and this is 1/4, so 1 by 4 centimeter square. So how many full squares are there? There is only one full square. So one full square, that is 1 centimeter square. How many half squares? 1, 2, 3 and 4. So 4 into half centimeter square. 4 half squares. How many quarter squares? 1, 2, 3, 4. So 4 into 1 by 4 centimeter square. So we have 4 half squares, 4 quarter squares and 1 full square. So when I multiply, I get 2 centimeter square, 1 centimeter square. So in total 1 plus 2 plus 1, 4 centimeter square. So this is the area of the square. In the same way, you can find out the areas of the shapes given in the chart. Okay, so do it by yourself. I hope you understand all the concepts and you can find out the areas of all the shapes given in the diagram. Okay, so students, as you have already learned about how to find out the area using a graph paper or using the concept of number of squares. So let's try with triangles. Can you see this diagram? I have drawn the similar diagram as it is given in your book. This is the blue triangle which is given in your book. So let's find out how many full squares are there. There are 1, 2, 3, 4, 5, 6 full squares. And let us count how many half squares are there. There is a half square because it is going through and through. And how many squares are there which are more than half? That is 1, 2, 3. So this is half square and these all are full square. So how many full square? 1, 2, 3, 4, 5, 6. 6 full squares, as we have already learned that each square is having area of 1 centimeter square. So into 1 centimeter square, so it is giving us an area of 6 centimeter square. This is a half square, so it has an area of 1 by 2 centimeter square, or I can say 0.5 centimeter square. The more than half squares, we have to take it as full because we are neglecting the squares having less than half area. So we have 1, 2, 3 more than half squares. So it will give us 3 centimeter square. Okay. So what should be the area of this triangle now? 6 plus 3, 9.5 centimeter square. So the area of this triangle is 9.5 centimeter square. Fine. Students, now we are going to discuss about the concepts given in page number 41. As you can see, it's a rectangle having 20 square. So the area of the rectangle is 20 centimeter square, as you have already learned that each square is having area of 1 centimeter square. Now concentrate on the blue colored triangle, as I have separated it out on the board. It contains how many full squares? 1, 2, 3, 4, 5 and 6. 6 full squares. And how many squares are there which are above half? 1, 2, 3, 4. So as I have cleared your concept that all the squares having more than half area are taken as full. So now I have 6 full squares and 6 squares having more than half area. So in total the area is equal to 6 plus 4, 10 centimeter square. As you can rightly see that this line is joining the two vertices of the rectangle. So it is dividing the rectangle into two equal parts. It's true over here. We have calculated that the area of this triangle is 10 centimeter square, whereas the area of the rectangle is 20 centimeter square. So it's half of the full rectangle. Let's go to the red triangle. Okay. Here we have 1, 2, 3, 4, 5 full squares. And how many squares having more than half area? 1, 2, 3, 4 and 5. So 5 full squares and 5 squares having more than half area. So in total we have 5 plus 5, 10 centimeter squares of area. So it's also half of the area of the rectangle, 10 centimeter square. So now we have found out that both the triangle, the red one and the blue one, is having same area. Both are having area of 10 centimeter square and both are having the area that is half of the area of the rectangle. That means each triangle is covering half the area of the rectangle. We might have done the diagram, or we might have done the triangles in two different ways, but the area they are covering is same. Understood? Now you can go ahead with the next sum and find out the area. Okay? Students, As you can see on this page, Suruchi has drawn two lines like this. So what is the area covered by this? If I draw a triangle, this triangle consists of 2 full squares and 4 half squares. That means the area is 2 centimeter square plus 2 centimeter square is equal to 4 centimeter square. A question might be in your mind, sir, how come this 2 centimeter square is added to 2 centimeter square? Because 2 centimeter square is for the full squares, and if we add half squares, 2 number of half squares, it gives us 1 centimeter square. So 1 centimeter square and 1 centimeter square, 2 centimeter square. So total area covered by this triangle is 4 centimeter square. Now what she does? She asks Asif, okay, you now draw another 2 line so that the area covered by the diagram comes to 10 centimeter square. So he comes and he draws 2 lines like this, as it is given in your book. See what's happening here. As he has connected the 2 lines drawn by Suruchi with his 2 lines, now he has 1, 2, 3, 4, 5 full squares. And how many half squares? 1, 2, 3, 4. So these all are the half squares. So in this area, what's happening? It has this square which is more than half, this is more than half, and this is more than half as well. So as I have already told you, all the squares having more than half area are counted as full squares. So 1, 2, 3, 4, 5, 6. So he has drawn 2 lines to give Suruchi 6 square centimeter of area. So the total comes as 4 centimeter square plus 6 centimeter square, that is 10 centimeter square. So here we go. Suruchi has an area of 4 centimeter square. Asif has drawn 2 more lines and joined with the lines drawn by Suruchi, which gives us an area of 10 centimeter square. Understood? So students, in the next page, it's practice time for you. You are given 2 tasks. In the first task, you have to complete the shape by drawing 2 sides so that you will have an area of 4 square centimeter. And in the second task, you have to complete the diagram with 2 sides joining the given sides so that the area will be less than 2 square centimeter. I hope you have understood the concept of drawing the shapes and finding out the areas, and I know you all are going to achieve your goal. Okay? Students, we have a third task and we are going to do it together. As you can see in the board, we have a rectangle having 20 small squares. So can you see what should be the area of this rectangle? Exactly, you got it right. It is of 20 square centimeter because it is having 20 squares of 1 square centimeter of area each. So let's draw a single line so that this rectangle can be divided into 2 equal triangles. How can you do this? We can do this by joining the corners, either these 2 corners or these 2 corners. Students, see, I have joined 2 opposite corners of the rectangle. Thereby, I have divided this rectangle into 2 equal triangles. Let me name it, okay, so you can better understand. Suppose ABCD is the rectangle. Now triangle ABC is equal to triangle ACD, because this is the line that is dividing the rectangle into two equal parts. It can be done in other way as well. How? If I join the opposite corners B and D, I will have two equal triangles BDC and ABD. Okay? So the other task is we have to draw a straight line, thereby dividing this rectangle into two equal rectangles. Okay? So as you can see, this rectangle is having 20 squares. So if I go to the midpoint 1, 2, 3, 4, 5 and draw a straight line over here. Now let the line be EF. So now EF is dividing the rectangle ABCD into two equal rectangles ABEF and FECD. So both these rectangles are having equal number of squares 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they are having equal area. Now the other task is we have to draw two straight lines in the rectangle and divide it into one rectangle and two equal triangles. It's too easy, you know. Let's do it. We have divided this bigger rectangle ABCD into two equal rectangles. Now we have to only do the partition in any of the rectangle, leaving the other one like that only. Let us go with rectangle ABEF. If I join the two corners B and F, so now as we have done it previously, ABCD was the rectangle and I have joined the line AC to separate the or to divide the rectangle into two equal parts. Same way I have joined the opposite corners B and F, so that rectangle ABEF is now divided into two equal triangles ABF and BFE. So we have a rectangle FECD and two equal triangles ABF and BFE. Got it? So let us complete the task by finding out the area of the rectangle FECD and the equal triangles ABF and BFE. Previously, we have divided the rectangle ABCD into two equal rectangles having 10 square centimeter of area. So, rectangle FECD is having area of 10 square centimeter. Again, we have divided rectangle ABEF into two equal triangles. So, each triangle will have area of 5 square centimeter, because rectangle ABEF is having area of 10 square centimeter. Okay? Dear students, this much is for today's class. We will meet in another class with some more concepts of this chapter. Till then, keep practicing and keep doing hard work for a better tomorrow. Okay? Thank you.